Hi, this is Joe and welcome to routerfreak.com. Today we're going to be talking about the ICND CCERT class, and in particular we're going to be going over what is a network. So what is a network? A lot of people, they start working on computers and networks and never really fully understand exactly what a network is. And eventually you're going to get to a point where your boss is going to ask you, why do I need all this stuff? You may be consulting on a job or at your current employer, and all of a sudden, you know, there's some capacity issues, or you need to change the way the network is set up, and you need to buy some equipment. And your boss is going to look at you and he's going to be like, what do we need? This stuff is expensive. Why do I need all this stuff? I just want to get on my computer, and I just want to send my email, or I just want to, I want to, write up a Word document, or I need to do my finances, or whatever it is that your boss does, and you need to just make sure that whatever it is he can do, his job is that he does, he can do it as best he can, and that's providing him with the best network that you can. And part of that is understanding what all this stuff does. What exactly are the routers and switches doing, and the firewalls doing, and intrusion prevention, detection, and voice over all these different devices that we have on our network. So when we have routers and switches, a lot of them come with different types of interface configurations, and they come with a lot of different types of features. You can get a router with built-in firewalls. You can get a switch that also can route. They can be stacked. They can do all kinds of different things. So you want to make sure that when you're proposing this kind of stuff and you get involved with this stuff, that you make sure that you're gonna look at the right device for the application and for the function that you need, and understand, that you're going to be spending your boss's money, and make sure that, the device that you buy is going to be the device that's going to work perfectly for the job, and allow them to grow in the way that they need to. So what we're going to go over today is we're going to be looking at some of the functions of a network and all the different pieces of a network. We'll also go over some network designs and some of the applications that are going to use this network. So so what is a network? Well, here we go. Here's a nice. I pulled this off of Cisco's website. I saw it. I was like, whoa! Now this is a serious network. And if you can look at all the different pieces and parts of this network. If you understand some of these, the Cisco icons that we have here. We've got way over here. We've got some IP telephony devices. We've got some servers over here. We got a multi-layer switch here. We got another multi-layer switch router connecting a DS3 from Rockford to San Jose, and then we've got another WAN connection from San Jose down here. It looks like to Dallas, or actually this is just a depiction of the WAN that connects New York and Honolulu and Dallas, Dallas-Fort Worth, Atlanta, all these different places. So this is kind of a network that eventually you may get yourself involved with, and you're going to need to understand all these different pieces and parts. But realistically, okay, so here's the basic network, right? We have a switch, we have a firewall, we've got a router, and it all connects all of our networks and our workstations out to the internet. So, back to that, why do we need all this stuff? So, why do we need a router, and what is a router, and what is it doing, and why do we need a switch, and what does that do? All this stuff, all this underlying architecture is, if you think about it, it's like the plumbing in your house, and we're all just plumbers. I hate to say it, but we are. You've got your house that's that you live in, and there are certain things you take for granted, like the water that comes into your house. You've got your plumbing. and the plumbing just kind of flows to your sink and flows to your bathtub, and it's that plumbing that we as network engineers, within the within all the computing and information that goes on day to day, that's what we take care of. We take care of that underlying plumbing of all the different devices. So a network is basically what, like we have here, it's just a collection of devices that all communicate together. It's the fabric that ties these applications together. So if you look here, we've got our switch and our firewall and our router, and all these pieces just all have their own purpose. You know, that we've got a this computer right here. Oops, this workstation right here. This is a guy. He's just sitting here. He's surfing the web, and he's going to come down here through the switch, kind of go through a firewall. And this switch, what is this switch here to do? Well, this switch is really just to let all these devices share the network. They're all going to share this uplink here to eventually to the internet. Now the firewall, well, the firewall is there as a security device. It's there to protect the network from intrusions and from all the bad guys that are out here on the network. It also, some firewalls also help with antivirus and not really spam, but they definitely do a lot of mitigation of threats to the network. And then finally we have our router. And our router, what our router is going to do here is it's going to make sure that all of these devices are able to route out to the network. So back to what we were talking about here. So the network is just really a collection of devices that are all going to communicate together over the network. And this ties all of our applications together so that they all can communicate. So what kind of applications are we talking about here? Well, we're simple browsers, FTP. FTP is for transferring files. So your browsers, you're looking at your Firefox and Google Chrome and Internet Explorer. Those are the most common, you know, that everybody pretty much gets on a browser and everybody surfs the web and checks their email, you know, gets on Instant Messenger, if I can spell right. Look at this, Instant Messenger. Database applications, especially if you're working for a large company, you've got these database applications that tend to track a lot of the inventory or manage customer relations. You've got email, which of course email, who would have ever thought that email was going to be as big as it is today. And of course, let's not forget games. A lot of people kind of laugh at games. It's like, oh, games, yeah, games. No, really. I got this little icon up here for World of Warcraft. There are, oh God, I forget what the statistics were, but there's like 40 million subscribers to World of Warcraft. 40 million worldwide. Each paying $14 a month. That's 14 times 40 million. So even if you're just talking a million, we're talking $14 million a month. So we're 40 times that. I'm not going to go into the math because really I would fail miserably. But all of these applications are what the network is here for. And these applications, basically, they're running here. They're here to support the users. And it's a client-server relationship where we have the user who needs to access the data, and then we have the data sitting out over here on the other side of the network. So what we're going to take care of is all this part here in between where the routers communicate and how they communicate and making sure that these packets from this client computer get to the server. These games, a lot of times what they'll do is they'll come out, you fire up your little World of Warcraft here, and they'll go out over here over the internet, over these routers, they'll hit this server. This server will come back to this client on a different port, And it's this constant back and forth communication. And we're going to get into a lot of different things. We'll get into talk about some of the ports that these games use and email uses, instant messenger uses, and these database, and web, of course. Web is port 80. But all these different applications that they use and how they use them. So what are some things that we need to take into account with these applications? Well, applications are, well, they have needs, and, and we as network engineers, we kind of gotta take care of these needy applications, and they all have different needs, and it's the more you can understand the applications that ride your network and how you can make the network better for those applications, the better of a network engineer you're going to be, and a better network that you're going to provide to your users. So there's several main things that I wanted to cover that your network is that you need to pay attention to, and that applications are going to need on your network. That's going to be speed, delay, availability, and reliability. And when we're talking speed, a lot of times, a lot of people they seem to feel like, oh, I know what speed is. Oh, it's 50 megabits a second and all this kind of stuff. But a bit, what is a bit? Well, a bit is really just a 1 or a 0, right? We're talking binary here. So a bit is really that measurement of data that's either a 1 or a 0. And that's the rawest form of what we're talking about on the traffic. Now, a byte is is 8 bits. So if you have 8 bits to a byte, one thing that I think a lot of people get confused is that we have a bit that are ones and zeros, a byte are 8 bits. So basically a word, or a letter I should say, a letter is 1 byte. 1 byte equals a letter. So if you can kind of start to get an understanding of the number of bits that go over the network, how that equates to bytes. Typically, network speed is indicated in bits per second. Now, if you're looking at computers, if you're a computer person, and you're looking at, say, storage, say, of a hard drive, or the size of applications on a hard drive, things like that, if you notice that those are measured in bytes. So you'll have a Word document is 12 bytes in size. Well, that's a pretty small Word document, but it's 12 bytes, essentially 12 letters in size. Probably less than that, because there's going to be the overhead of the document itself. But my point is that the difference here is a little b and a big B. Bytes versus bits. A little b or a big B or a little b. And so if we're talking 10 kilobits per second, notice we have a little b versus 10 kilobytes. Oops, let me do that right. Kilobytes per second. This is 8 times as much as this. So really, if you're a lot of times the way we need to figure out our speeds is make sure that we're understanding the difference between the bits and bytes. Of course, then we start moving up in size, and a kilobyte is really 1024. It's really 1024 times a byte, right? And then a megabyte is another 1024 times a kilobyte. And I should be using the big B. See, I'm bad about it too. I'm over here, little b, big B. But essentially that's how it goes up. And then a gigabyte is 1024 times a megabyte. And it keeps going up. Megabyte, gigabyte, terabyte. Think of beyond a terabyte as like a petabyte and then a yottabyte, and it just keeps going and going. But the thing that to take away from all this is that when we as network engineers, we are usually referring to speed in bits per second and not bytes per second. Another thing that applications need, or some applications need, are the lack of delay. I'm trying to see of a good way to put this. So delay, what are some applications that would ride the network that are very susceptible to delay? Well, one is voice over IP and phone conversations. Voice over IP and telephones, well, they're as your network gets bigger and you're making these phone calls over larger distances, then you have applications like voice that are very, very reliant on not having much delay between the send and receive, and they'll buffer and they'll do things and they'll provide quality of service where making sure that if there's any congestion that the voice always gets through. There's nothing like I'm sure you've been on a phone call and you've heard delay. You've maybe said, "Hi, Mom," and then all of a sudden, 5 seconds later, she'll reply, "Oh, hi, how are you?" And that delay it can be a little cumbersome when you're trying to have a conversation. So what we try and do is we try to minimize that delay, and then we try to also minimize any kind of garble or corruption of the packets on the way, because that's not any good either. So the next thing that many applications are going to need are availability. You've got some pretty you may have a bank or a security system that relies on the network, and if the network is down, well, your security system is down. Or if the network is down, then the bank may be security systems for the bank. So, I guess the question here with the availability, going back to our analogy of plumbing, is the water still on? I mean, do we still have water? Do we pay the bill? And really, when we're talking about networks, we're more talking about availability from in the case of if there's a failure. So what we do is we'll create high availability systems where we'll have a router, and then we'll have maybe a secondary router sitting here as a backup. And if this router goes down, then the backup router takes over, and things like that. And so we want to a lot of times especially for business applications where the business is relying on the network to be up. We need our databases to be up. And I worked for Match.com several years ago, and Match.com, if you know who they are, they're a large online dating service provider, and they're 24/7. They're an internet-based company. They're up all the time, and people are always online looking for love, no matter what time of day it is. And if we ever had any kind of issue, well, we had to make sure that we had highly available systems that were up. So if any of the routers went down, we had a backup there, because these are paying customers, and they're there to Match.com was there to provide a service to those folks. And if the network went down and we couldn't provide that service, well, they're paying for nothing, and that's not good either. So you want to make sure that your network is always there and always available for your users, and that kind of goes into reliability as well, where you can rely on your network to be there, rely on that plumbing, so to speak, to be there. So so that's the big thing that several things that we want to make sure that we understand as far as the needs of our application. So network designs. There are a lot of different types of ways that we can design our network. I have listed here just 3 of your basic network designs. You've got a bus topology, a ring topology, and a star topology. So network design's a design and a topology. I just threw that word out. So topologies are basically these designs of these networks, and different ways that networks can intercommunicate with each other. So, and a bus topology is basically just a single network segment with computers hanging off of it. This is kind of more of an older style, dating back, before a lot of the Ethernet technologies came out. Ring topologies. This is kind of more in line with some older technologies. Token ring, for example, where there was a ring that interconnected all of the network devices, and there was a token that was passed from device to device to device around this ring. And if your device got the token, then it meant that it was your device's time to talk on the network, and then that message would get sent out around the network, and anybody else who would receive it, they would get it, and then the token would go to the next person, and it was kind of a big round robin thing. And then finally, star topologies, and this is more common in Ethernet networks that we see on the local area network, where we have all of our devices come back to a central location in like a telco closet or something like that. So now we start getting into some bigger designs. What kind of design do you think this is? Well, let's see. We got some star topologies here, but then all these switches are along. What is this? This is like along a bus. So we have a bus topology, but we also have some star topology going on. What kind of topology overall do you think this is? Well, really, it's a hybrid, right? And that's kind of what networks are. If we look back at that big giant network that I had up here a while ago, look at all these different things. We've got star topology here. This is a star. This here may be considered a bus. So we've got a lot of different types of topologies on our network, and it really comes down to what we can design that makes the best sense and the most optimal sense for the network and for the applications. Remember, because always goes back to our applications and the applications that ride the network. We're just the plumbing. We're not the water that runs through it, and so we want to make sure that our packets are flowing through our network in the best way it can. So what have we talked about today? So kind of talked about the function of the network and what it is and why we need all this stuff, and talked about how, well, it's basically just the plumbing, right? It's the plumbing on our network. We went over all the different pieces of a network, the router and the switch. Network cards are in our computers and our laptops that give us access to the network. And then, of course, there's the internet. There's also firewalls. We talked about firewalls that provide security. All of these devices are pieces of the network. We went over applications, the different applications that all use the plumbing. We've got our web browsers and web surfing, email, and gaming. We also talked about all of our different types of network designs that we can have. We can have a bus design, a ring topology, and a star topology, and how all of these designs and all of these different topologies you can have a hybrid and a combination of all of them together, depending on the needs of the network and depending on what you need. So that's about it, and I hope you like this lesson here at routerfreak.com, and I hope you come back and enjoy some of the other lessons that we have. So that's it for me, and I hope you have a great day, and I'll talk to you soon.